Welcome back, everyone, to On.net. I'm your host, James Montemagno, and I'm real excited because you may have heard about dev tunnels, but the question that I have to ask, and we're going to investigate today, is what are dev proxies? And I have two of my best friends in the world to help out with that, Garry and Waldek. How's it going, guys?
Doing good. How are you?
I'm doing great. Now we've seen you before on .NET Conf. We've had Garry on talking about Teams Toolkit stuff. We have all sorts of amazing stuff that comes out. And I think from a developer point of view, when I first saw Dev Tunnels, for example, it made a lot of sense. It was, hey, I'm running services locally on my machine, and I want to kind of expose those to easily debug those, share them with friends, or like if I'm debugging a mobile app, it made a lot of sense. But y'all reached out to me and said, hey, we have this new thing called dev proxies. And I was like, I have no idea what that means, but like, what the heck is a dev proxy? So what the heck is a dev proxy?
Well, Dev Proxy, simply, it's a tool, right? It's a command line tool, just like Dev Tunnels. But we're in the industry of breaking things, right? It's like we build apps, yeah, and we test things, and we want to make sure everything's working, right? We test the happy path. So that's all good. Everything's perfect. We go on with our lives. But the real world is different, right? It's not always perfect. Sometimes things go wrong. And one of the things that can go wrong are APIs. So what happens when an API that your app is dependent on just stops working? That could be, throws an error. It could be it starts throttling you or rate limiting you. Like, how do you test these scenarios? Like, they're pretty difficult. So that's why we built Dev Proxy, to basically make that as easy as possible so that you can just run this tool and really quickly test your app, right? You don't have to change a line of code. You can just run your app as is and just see what happens. And I think the best way of showing that, right, is to just show you the tool. And let's get into it, and I'll show you what Dev Proxy is all about.
Yeah, that sounds great. Let's do it. Let me bring up your computer. Let's go. Boom.
So let me show you what all that means. So I'm in the command line at the moment, and if I want to send a request to a cloud API, I can do this from my terminal. I can send this request over and over again. It's just going to return a response, right? It's a cloud API that I don't own, but it's not under any stress. But what if I'm building against this? What if I want to simulate an error and I'm just not getting an error? How would I do that? Well, one way that we can do that is by using Dev Proxy. So let's run Dev Proxy from the command line. And now it's running. What it's doing is basically looking out for requests that are going over the network to an address that it knows of. And when it finds a request for that URL, it's going to send back an error response. So now let's switch back to the other tab, and we'll send some requests now that Dev Proxy is running. So it's taking a little bit longer here, and I've got an error. Too many requests. Okay, so we've got a 429 response. If we look back at Dev Proxy now, we can see that Dev Proxy has intercepted that request and has basically sent a chaos response back, so a 429. And we can just keep repeating this, and we can get random errors again. So here we've got the 418. I'm a teapot. There we go. Different errors. So how is all this being accomplished? So with Dev Proxy, we have a config file. Okay, and you can set this config file up to, in this case, we've got random errors. But there's all sorts of different behaviors that an API could show. So throttling is one of them, rate limiting is another. Things like latency as well. So if you want to introduce like slow responses from a server and test that as well, you can use Dev Proxy to help you do that. But what we have in here is we've got a plugin system, and each plugin injects a behavior. So we've got generic random error plugin, which has some configuration. And this configuration points to a file that contains errors. So if you look at this file, this dev proxy errors file, you can see in here that we've got a collection of error responses that proxy can just return. And at the moment, we've got some standard 400, 500 errors that can be returned. And we could say every request that is sent to this API could fail, or we could have a percentage. So maybe you want 50%, just so you can have some requests pass through and not all fail. Or if you just want to test a particular scenario, say 429, you could just have the 429 error in here. One of the things that we also do with 429s, you generally get a retry header in your response. So, I've got too many requests now, but try again in 5 seconds, and chances are you'll be able to get through, or maybe not. But your code needs to handle that, right? It needs to understand, okay, I've got this value coming back, I need to back off before I then try again. And we've got functionality in Proxy that helps you do that as well. In terms of the plugins, we've got lots of plugins out of the box, doing all different types of behaviors and adding different functionality. But at the base level, Proxy is there, sat looking at the network. It's looking at these URLs that you want to watch, which I have here. I just have this one URL and a wildcard. So anything to this host name is going to get picked up. But I could be, a lot more verbose here as well. I could just look for specific endpoints or specific domains as well. Have as many in there as I like as well. So if I want to test multiple APIs, I can do that as well. And with that, what I'm going to do is hand over to Waldek, who's going to show you an even better example of using Dev Proxy.
No, that's really cool. I mean, it's a good kind of overview because I'm so used to actually like messing around with emulators and simulators. And this type of stuff is hard because, like the Android emulators, for example, as a mobile dev, do give you some granular control over like network speed. But again, that's like of the device, not actually of the API. So what this is doing is actually simulating what would happen on the server and those proper responses. So as a developer, what I think is cool about this is I'm never thinking about all the different things that can go wrong. But if I have a config file like this, I could actually in my, client or my web app and my client app, test for those different scenarios and make sure it's a good user experience at the end of the day. So that's really cool, just having that simple config file and then doing local dev just to test out whatever I'm doing locally, or if I have a test server, right?
Yeah, exactly. So, those scenarios like throttling and backing off and latency, you need to have that affordance in the UI, right? Your users just going to be sat there kind of waiting, thinking, is something happening? Do I need to hit F5 again? Like, you want to simulate those things. You want to see them whilst you're developing, not just when it happens or assume that it's going to happen as well, which testing is difficult. Sometimes you have to compromise.
Yeah, and I think the thing that you pointed out, which is important, is these can be APIs that you own or just APIs you're integrating with. That's often what I'm doing is I'm integrating with third-party services. Like you said, you have no control over this at all, but now you do from your dev perspective, which is super cool.
Exactly. Yeah.
Awesome. Well, I'm ready because, command line's cool, but me, what does it look like in a full production app? What do you got for us, Waldek?
Absolutely, right? So we've got a demo app, which you might already know, right? So this is the .NET Aspire brand new app that shows you like how Aspire works. And it's like typical thing you might build, right? It's a web app with APIs, containers. It has a bunch of stuff, and it's just a web shop, like typical thing you would build with overview of products that are being pulled in from a catalog. So it's just like a nice web app to test, and it all works, right? So how about we see how robust this really is? How, resilient is this against API errors? And let's throw a wrench into it and see if it still stands. How about that?
I'm excited because I want to see what Fowler and Damien have coded into this and the entire engineering team when we talked about this at .NET Conf. And I don't know, because I do know this is a cloud native app with many, many services, right? Inside of it, a lot of microservices talking to each other. And I know there's resiliency built in, so I'm excited to actually pop around.
Exactly. And I hope that won't get us into any kind of, problems with the team.
Listen, if we're not getting in trouble with Fowler and Damien, then we're not doing something right. So
perfect. All right, cool. So here is on the screen, you see all the APIs that run as a part of this app. And in this case, let's see how the app will respond to errors that are coming from the catalog API. So let's say that there's something wrong with the API, or, the case where the app is so widely used. There's a bunch of folks. Basically, we are out of limits, right? So let's see how resilient that app would be. Let me go to terminal. And basically from the dashboard, what I want to get is the URL of this API, right? So the catalog API runs on localhost 5222. So I keep note of that. Let me go to the terminal and let me in here start Dev Proxy. My terminal starts Dev Proxy, and I want to watch again for all requests going to that URL, right, from my box. So I'll do that. In parallel, let me restart the app and then ensure that it's got attached proxy to it, right? So in here, I want to restart the app and then say that proxy is enabled on this URL. So let me do that. It will take a moment to spin. All right, so the web app is now live, rebooted. Let's go back to our dashboard just to see that everything is on, that all services came back. All right, so everything's working here. Our catalog API is on. Let's now go back to our app. Let's see how well it's built. Something's loading. It's not as fast. The question is it my computer or is it Dev Proxy simulating latency? Let's see. There you go, an error, too many requests. What's wrong with that? Let's go back to the terminal and see what Dev Proxy has done for us. So if we go all the way back, right, there's a bunch of requests that passed because we didn't watch out for those, right? Like we only wanted to look at the request to the catalog, which is 5222. Right, so everything else will just pass through. And then here we've got the first activity, right? So we've got the chaos. We simulate errors, right? So these are errors that otherwise it will be really hard to mock. Otherwise, other than like you need to write some code that mocks these errors. Whereas here, we didn't change anything about our code. We just run it. And we've got these errors now, and we can see what the app does, right? So we did a single refresh of the page. And if you look at this, like you will see that there's 500, 503, another call. Like, so how come that we have all these calls from this single page? Well, the cool thing is that the web app has built-in resiliency, right? So when it will hit an error, it will wait and it will retry again. But that these retries have a limit. Like I think the app is set up to retry 3 times, and on the 4th time it will fail, right? So that's exactly what we see here. You know, there's a call, there's another one, it waits, backs off, and then it fails. And then there's another interesting thing, like why do we see fail here on a 429? Well, the reason for that is that we've built in proxy this thing that allows you to check. When you get a 429 with a response, retry after. So basically that instructs you, wait for that period of time until you try again to kind of give the API time to, to cool down. We have a thing that checks, do you actually wait that time? So here we had a request instructing you wait, but then we're issuing another call. And the reason for that is that we have a web page that's doing 2 or 3 calls in parallel. And basically the first one calls, it gets instruction to wait, and then the other one does not check if there's anything else. So in other words, like we don't have a page wait controller. So we just issue another call, basically hurting the API again, incurring additional load. And that's exactly what we say here. Hey, like we told you to wait, you don't. So we failed that explicitly. This isn't chaos. Like we saw that you're doing something that we told you not to. So this is a failure. So this is a hard fail, right? So let's have a look. Let's try another one. So let me clear that. And let's do another reload. Maybe this time it will come through. Something's loading, something's here. We've got the page with the products, but we are not having filters. Where are the filters? Right? And let's get back to terminal. Maybe we'll see how it all works. There you go. And it's also an interesting thing, like the way this web app is built, right? So we had a part of the page loaded already, but because some other part failed, the whole thing now fails. So that's kind of like room for improvement that we could do in the app, so that if one portion of the page fails, it's not the whole web app that will fail. And again, with an exception. And basically our API at this point says, I am a teapot.
That's wild. That's wild to see it. Like, like you said, like parts of the application were up and running, spinning properly, you're getting everything. But as those errors start to unfold, some of that wasn't handled properly.
Definitely, right? So let's have a look. What setup that we use for this test, and maybe we can do a quick fix for the web app.
Yeah, that'd be awesome.
All right. So the config that we used, basically we simulate three things, right? So first is the retry after, which is kind of the guidance that we offer, that every single time you've got a 429 with the retry after header that instructs you how long you should wait, we're going to actually check if you wait for that given amount of time. And if you don't, that is exactly the hard fail you've seen. Not the chaos, but really the hard fail. Then we've got the errors, right? So we've got some random errors here. IMTPOT, 2-minute requests, 500, 503. So basically all the things, that happen in real, but that are so hard to simulate, to test with APIs, and especially with APIs that you don't own, for which you don't have a code, and you cannot call anybody and say like, hey, could you please fail your API because I'm building my app, right? That doesn't work. Right? So these are basically errors that we put in here. And again, if you build your own API, you want these errors to be basically the errors that you could get in real. And you can add in here your status codes, your body shape, the headers, right? So that for example, if you use an SDK, that SDK will get the exact error that it would get from a real API, so that it can deal with that in basically as close to real way as you can, right? And then the final part that we've got is the latency. So again, something that we already talked about, which is, what if my API is slow? Like, how do I communicate it in the web app to users? Because again, like you want to click something and there's like, okay, so is this page done or not? So basically that allows you to check, do you have all affordances in the UI in place to communicate to users? Well, this isn't expected, but it's taking a while longer. Wait, do not click, do not cause additional requests, right? And here for the latency, we can say we want to delay every call that we intercept between 200 ms and 3K, right? So basically you will get a random value from this range. And again, you can adjust them to test different cases. And the cool thing is that this applies to your server-side calls, client-side calls, whatever calls you've got that are going out of your box, right? So this is really a great way to test kind of the experience of your app end to end.
Yeah, that's super cool to kind of see exactly the fine tuning that you have control over what you want to test, and even down to the milliseconds. That's really neat.
Yeah. All right, cool. So let's have a look at the web app and see if we can add some try catches around the calls to basically not have the app fail in such a miserable way that it just goes blank, right? So yeah. One of the pages that we've seen fail is the catalog page, basically the homepage with the filters, right? So here, like we load the results, and I think we do it a bit down here, right? So we have the API call. And right now, originally, it's just an API call. So how about we wrap it in a try catch? And then basically, yeah. Right, like you want to ensure that, when there's an exception, you do something with that. And then basically we assign it to a message, right? So here, let's define a variable for us to hold the message. And then we show the message to user, right? So we basically tell them, there was an error. So that's the one thing that we do. Another thing that we've seen, like the page itself, then there was another thing, the filters. We saw at some point that the page was there, the page would work, but then the filters didn't, and eventually the filters caused the whole page to break. So that is what we've got here, the catalog search. So if we go here, again, the same thing, we're loading the catalog brands, and we do it in here. Again, no try catch, we get the brands, get the type, but if anything of these things fails, the whole thing fails. So again, let's wrap it in a try catch. Let's wrap it in a try catch. There we go. This one. All right. And then let's add a variable for our error message. And again, if something goes wrong, let's show it to user. All right. So we've got that thing here. And I think for now, let's have a look what kind of effect that has on the web app. There you go. Starting. API is almost done. All right, I think we are good to go. So we are again on the catalog page that we have just adjusted. So now we see loading. Everything's still on. Let's have a look at proxy. Did it throw some errors? It's passed everything through. Of course it does, right? Because like again, we set it up with a fail rate, right? So that also gives you the ability to say how many of the API calls that you do from your app you want to fail. Do you want to fail all of them, meaning nothing will ever work, which is not really real, right? Or you say that you want to have a 0.5% chance that things will fail and so forth and so on, right? So we set it to basically have a 50% chance of an API call to fail, which is why, by coincidence, we saw everything pass now. But let's give it another shot. Let's see if we can break it, if we can see some errors on our screen, and what the web app will do. So things loading, there you go. An error has occurred while loading filters, and the page is still on. So we're seeing errors. The good thing is the web app itself didn't crash, right? So we have improvement. It's maybe, not ideal thing they want to show, but we like the app doesn't crash all of it, right? Like we're not seeing an empty screen with a stack trace. So in a way, I guess that is an improvement, right?
Yeah, that's amazing. Because now, again, as we're running and doing this with so many different, microservices that are running, this is really going to allow those different elements of the page. And of course, you can improve the look and feel of that over time. But now you actually saw the functioning app, which is cool.
Yeah.
That's awesome. That's so neat to kind of see it in action in a full production application and just tweaking it and actually just kind of massaging the code a little bit. And it's already improved and of course not crashing because you don't want anything to crash. So where can people find Dev Proxy? Where does this thing exist on the internet?
So the easiest place, short link, aka.ms/devproxy. That'll take you straight to our docs. We have a get started tutorial on there as well, which will go through kind of just how to get Dev Proxy set up on your machine, and then how you can actually then configure the Dev Proxy to work with your own application, so you can test your own app, in a matter of minutes, without having to write a line of code. Try it, test it out. Verify that what you think is gonna work, right? That it's actually, you get that confirmation that everything is good, and if not, then you can go and fix it, and you can recreate these, really hard to recreate behaviors from the APIs that you're using.
Well, this is awesome. Garry, Waldek, thank you so much for coming on, showing it off. And of course, I'll put links to everything in the show notes below. And now we're going to have to go make some PRs against eShop. That is for sure. So thanks, guys, for coming on, and I really appreciate it.
Thank you, James.
Awesome. Well, thanks all of you for tuning in. If you have any questions for Waldek and Garry, make sure you leave them in the comments below. And if you're over here on YouTube, make sure you jam that subscribe button and ring that notification bell so you get updates every single time we put out another video. Well, that's going to do it for this week's On.net. So until next time, I'm James. Thanks for watching.